right, so today we're doing lesson 7.5, which is on solving radical equations. So solving equations where you have some kind of root. So you'll see an equal sign, and that's how you know you're solving an equation. And so there's just a few steps that you have to follow to solve these. The first one is to isolate the radical on one side. So that means you only have the radical and what's underneath of it. If there's something being added or subtracted outside of the radical or something being multiplied in front of the radical, you've got to move that over first. And then we raise it to the power of the index. So if it's a square root, we're going to raise it to a power of 2. If it's a cube root, we're going to raise it to a power of 3, and so on. And then you just solve the equation. Now, there is one extra thing that you always have to do, and that is to check for extraneous solutions. And that means sometimes when you solve the equation, you'll get an x value that when you plug it back in actually doesn't work. And so you have to check for those. So at the very end, you have to plug your answer back into the equation to check it. And it does come up sometimes that it doesn't work out. And so sometimes there will be no solution if your answer didn't work. Sometimes you'll get multiple answers and one of them may not work. So number one, we have to get the square root by itself. So we're going to subtract 5 from both sides. And that gives me the square root of x equals 7. And to get rid of the square root, I have to square both sides. And so a square and a square root undo each other. So this becomes x equals, and what is 7 squared? 49. So before we decide if that's truly the answer, we're going to check. And so I'm going to go back and plug in the square root of 49 plus 5 and see what that equals. So just, whoops. Square root of 49, make sure that plus 5 is outside. And I get 12, and I should have gotten 12. So that means that this is a solution. All right, number 2, what step do I need to do first? So we have negative 4th root of x equals negative 3. Next, what do I do? Divide by negative 1. So this will be the 4th root of x equals positive 3. And now I'm going to raise both sides to the power of 4 to get rid of the 4th root. And we get x equals, what's 3 to the 4th power? 81. Good. And so we'll go back and check 3 minus the 4th root of 81 and see what that equals. To get the 4th root, if we go to math and go down to number 5, that'll let us type in whatever root we want. It was 81. And we got 0. So that one is a solution. Number 3. What do I do first? Subtract 10. And we get the square root of x plus 7 equals 1. And then I raise both sides to a power of 2. You don't want to subtract 7 here because that 7 is underneath the radical. You can't just pull something out of the radical. Got to get rid of the radical. And so this becomes x plus 7. What's 1 squared? 1. And then we subtract 7 and we get x equals -6. And then over here, check. And I do want you on these problems showing that you checked it. So write out this part. -6. So 10 plus the square root of -6 plus 7. And when I type that in, I do get 11, which is what I was supposed to get according to my problem. All right, number 4, what's my first step? Subtract 10. So square root of 6x minus 5 equals -7. Here's a hint that this one's probably not going to work out. Can you ever take the square root of a number and get a negative? No. So this one's probably, when we type this one back in, it's probably not going to actually work. But we got to double check anyway. So now I've got everything outside of the radical, so square both sides. And we have 6x minus 5 equals what? It's what? 49. Yes, 49. Positive 49. If you don't put that -7 in parentheses, your calculator is going to tell you -49. But you should know that when you square something, it's always positive. Then I add 5 to both sides and get 6x equals 54. Then I divide by 6 and we get x equals 9. So we have to go check it. The square root of 6 times 9 minus 5 plus 10. Let's see what that equals. Make sure that you do your plus 10 outside of the square root, so you have to arrow over. And we get 17. It was supposed to equal 3. So it does not work, meaning there is no solution. Now this next one, I have a fraction as an exponent. So we know how to rewrite that as a radical. Negative 36 equals negative 9 square root of x minus 12. So a 1/2 exponent gives me a square root. Step 1 is to divide. That's negative 9 times the square root. So divide by 9, negative 9. And we get 4 equals the square root of x minus 12. Now this is a square root, so we raise to the power of 2. And that gives us 16 equals x minus 12. And then if I go back and add 12, we get 28 equals x. We'll go back and check. Now when we check, we're going to do exactly as the original problem is. We're not going to, technically the square root's the same thing, but it's always good to go back to your original. And so I'm going to type in over here, negative 9, 28 minus 12 to the 1/2 power. And we want that to be equal to negative 36. And we do get negative 36. So that's the bad thing about these questions is you really can't go back and check your answer to know for sure if it's correct. Because, even if like on this one, you didn't get 3, that meant it was no solution. Doesn't mean that you completely worked this one out wrong. So you can't 100% check all of your answers like you can on a lot of the problems. Number 6. How do I write this one with a radical? Cubed root of 7x minus 1, and that plus 11 is on the outside, equals 7. We'll subtract 11, and the cubed root of 7x minus 1 equals negative 4. What power do I need to raise this to? Yep, power of 3. Because it's a cube root. And we get 7x minus 1 equals negative 64. Then we add 1 to both sides. 7x equals negative 63. And then divide by 7 gives me x equals negative 9. And we're going to go over here and check to see if this truly is a solution. So 7 times negative 9 minus 1 to the 1/3 power plus 11. And I get 7, which is what we wanted. So this is a solution. All right. Let's try number 7. Actually, I want you to go ahead and work on number 7 and 8 by yourself. All right, number 7, add 9 first, then raise to the 4th power, then subtract 12, divide by 8, and you get 1/2. But when we go to check it and we plug it back in, it gives us -7. So there really is no number that'll work in this problem. And kind of my hint on this probably isn't going to work is I knew when I had the 4th root of something equals -2, your 4th root can never equal a negative. So I knew that this one probably wouldn't work out either.
I have a question.
Yes.
I think that I'm wrong, but would the 16 be a -16 because it's -2 to the 4th root?
Make sure you put your -2 in parentheses. If you don't put that in parentheses, it will give you a -16. Yep.
Thank you.
Same with squared. Really, any even exponent. Now, if it's an odd exponent, you would get the same answer. But if it's an even exponent, if you don't put it in parentheses, you will get the wrong answer. All right, and then this one, you needed to subtract 18 first and then divide by -4. And so we had a square root equal to +5. Solve that down, we get x equals 6. And then when you plug that back in, it did equal -2. Any questions so far? All right, number 9, we have a square root equal to a square root. So we're just going to raise each side to a power of 2 from the get-go. And that gives us x minus 8 equals 43 minus 2x. If I add 2x to both sides, I get 3x minus 8 equals 43. And then adding 8 gives me 3x equals 51. So x equals what? 17. Or so we think. We have to double check. So this time I will have to plug in on both sides and see if I get the same answer for each. So if we do the square root of 17 minus 8, you should get 3. And the square root of 43 minus 2 times 17, you should also get 3 on that one. So those two are equal, which means it does work out. Number 10, I need to raise to a power of what? 4. This only works if you have a 4th root equal to a 4th root. I'm not going to give you any problems where you have a cube root equal to a 4th root. So we get 27 minus 2x equals x minus 3. I add 2x over, or you could subtract the x to the left, either way. But I'm going to move this over there. I would have 27 equal to 3x minus 3. And I'm wanting to get the x by itself. A lot of times people say subtract 27. Well, then that leaves nothing over here. You want to add the 3 to both sides. And get 30 equals 3x. And then dividing by 3 gives me x equals 10. All right. So we have the fourth root of 27 minus 2 times 10. Get 1.63. And the fourth root of 10 minus 3, we get the same thing. So 10 is the solution. All right. I have 4 more. You're not really going to like these probably. Number 11. Is there anything to add, subtract, divide at the beginning? No. So raise to a power of 2. And this gives me 8x equals x squared. So when we have an x squared, the way that we solve these is by getting everything to one side and then either factoring or doing quadratic formula. All of the ones that you get are going to be able to be factored. But if you just prefer quadratic formula, that works too. So we don't want a negative x squared. So we're actually going to move this 8x over to that side. And we would have 0 equals x squared minus 8x. Now, what do I need to do with this? Right here. What do those two terms have in common? They have an x. So factor out an x, leaving me with x minus 8. And so once it's factored, you set each factor, the x and the x minus 8, equal to 0. And so we will have possibly 2 solutions on this one. So if I do the x equals 0, if I set x minus 8 equal to 0, what is that? X equals 8, yep, positive 8. And so we have to check both solutions. So I want to know if the square root of 8 times 0, I want that to be equal to x. I want that to be equal to 0. So if you need to type that in, square root of 8 times 0, oops, it is 0. So that one works. Then try the square root of 8 times 8. We want that to be 8. But let's make sure. Yep, it's 8. Both of those are solutions. Number 12, what do I do first? Subtract 7x, and we'll get the square root of 12 minus x equals x. And then raise both sides to a power of 2. And this gives me 12 minus x equals x squared. Now we want to get everything over on the side with the x squared, so I'm going to add x to both sides, and I'm going to subtract 12. I'm just going to do that at the same time just to save some room. So this would be 0 equals x squared plus x minus 12. Do we have a GCF? No. So we have to factor this. Meaning you want two numbers that multiply to be negative 12 and add to be 1. What? Positive 4, x plus 4, and x minus 3. So I would have x equals negative 4 and x equals 3. And we want to check both of those. So this first one, when I plug in negative 4, I want that to be equal to 8 times negative 4, which is negative 32. So let's see if it's equal to negative 32. It's not. It's equal to negative 24. So this one doesn't work. Let's check the other one. 12 minus 3 plus 7 times 3. We want that to be equal to 8 times 3, which is 24. And it is. So the only solution on this one is 3. All right, we got one more. We'll probably stop with this one. This one, I have the square root of 6x minus 38. Do I have anything being added or subtracted to this radical? No. So nothing to move over. You don't want to add 5. That's just going to put it a plus 5 on the outside here. So we go ahead and square both sides. And we get 6x minus 38. It is not equal to x squared plus 25 or x squared minus 25. When you have x minus 5 squared, it's like this. So you need to FOIL or do the box method. And if you want, we will cross out this one, and you can just use this space over here for that problem, because you don't really have room for the box. X minus 5, x minus 5. get x squared, a negative 5x, a negative 5x, and 25. So we have the 6x minus 38 equals x squared minus 10x plus 25. We're running out of time, so I'm going to go kind of fast. I'm going to move both of these things over. So I'm going to subtract the 6x and add the 38. This would be minus 16x plus 63. And if I factor this, the two numbers that multiply to be 63 and add to be negative 16 are negative 9 and negative 7. So that leaves me with x equals 9 and x equals 7. Oops. I need to check those first before I box them in. But they both work, actually. So if I do the square root of 6 times 9 minus 38 and see if that's equal to 9 minus 5, it is. And if I do 6 times 7 minus 38, square root of that, and see if that's equal to 7 minus 5, it is.